Hey, today I'm going to give you an overview of Embed. I'm using this pressure sensor from ST as an example. We're going to go all the way from datasheet to configure digital component model to bring up where we're going to test this chip on physical hardware and generate a driver library. Let's go. First, I'm going to upload datasheet for this component. I'm going to go select the file and open it in Embed Explorer. So now as it's uploaded and processed, we can go and click documentation, and if we click on the PDF name here, we'll actually have a file opened, the one that we uploaded for processing. We can go then configurations, open the system configuration, and go to general info, where we'll have all of the information about the component itself. Name, vendor, interfaces. So here we have I2C and SPI. I'm going to select I2C for this. I can see that there are two addresses for this component, 5C and 5D. I'm going to select 5D because that's what it's connected to in my setup. We have all of the registers extracted for us. You can scroll down, and here we can see name, address, size. If I'll open it, I'll have access types, delays, defaults, description. Everything is editable, so if I want to change access, I can do that from read to read write or whatever I need to. There is a bit location. I can click on every field. I can see description of them, and everything is editable as well. So I can easily drag and reduce the size of the offset and then save it or cancel it. Everything is also backlinked to the PDF. So if I click on the name of the register, it will open the page where it was extracted from. So let's close that and go to commands, data types, events. All of that is pre-extracted for you. For this, important is setup. This is basically an initialization sequence, and we provide a narrative that allows you to quickly understand what you need to do to start the device. So we click on select registers and select the registers we need to have. In this case, it's control reg 1. For here, we'll need to configure output data rate, ODR. So I open it, I find field called ODR, and I select frequency I want to use for data retrieval. Perfect. So here we have a decimal value that was calculated, can be converted to hex as well. If I'll scroll down, we can also see that we need to select FIFA mode, and we need to configure FIFA control to select desired FIFA mode. So I select FIFA control, I add it to setup list, I can open it up and then find the F mode offset and select it into the bypass, which is 0. I can also set the sequences by just dragging the registers within the setup. Now let's go to formulas. Here I can combine registers and create formulas. So I go back to registers and I see how registers are created for pressure and temperature. So I can click on the backlink mode, select the register for temperature, let's say, and here will tell us that the temperature output value is 16-bit data that contains the measured temperature. So we need to combine temperature H and temperature L registers for high and low bit. Same for pressure. And here, if you'll read, we'll actually see that there is a section 4.4 on interpreting pressure readings. So same for temperature. I can go back to formulas. I now know that I need to first combine both temperature and pressure. So I click combine, create a combined register name, temperature in this case. Then I'll go and select registers that I want to combine. Importantly, they're combined in user selected order. So we have high and then low byte. Great. Now same for pressure. So I'm going to call this pressure and select the registers that I want to be combined. Pressure out H, L, and XL. Perfect. This is now saved, and we can create a formula. As we see in the datasheet, we'll need to divide values that we read by a specific sensitivity figure. So here it's 4096. So I select pressure register that we created and divide it by 4096 and save it. Same, let's do this for temperature. So I create a formula name called temperature. I insert the register temperature that we've created, a combined one, and divided it by, let's have a look, by 100. Perfect. So let me type this in and save it. Now I have both formulas ready. Let me close the PDF and go and generate testing environment. So I go generate testing. First of all, what I'll need to do is select board that I'm using for this integration. In this case, as mentioned at the beginning, it's WB55RG. So I select that and I can click Get Firmware. What happens at this point is you are saving a hex file with firmware into your computer. So let me pull up the STM32Cube programmer, connect the board to my computer, and connect it to the Cube programmer now. So make sure that you have firmware upgraded to the latest version before you do that. So first I'm gonna erase full chip flash memory. Let me do that. And now I'm gonna go and actually upload the firmware that we've downloaded from Embed into this board. So I'm gonna go select my hex file and start programming. So within a few seconds, perfect. I can disconnect, it's done. Importantly, please disconnect your device after you flash the board and reconnect it again. Now, we go back here, we select data exchange frequency, let's say half a second, and we click connect. Select the COM port, and now we have status update. Yes, perfect. We can read the buses, we've connected the address, data transfer is successful. We can go to registers and see live readings for each register. That updates in real time. We can see that formula values are being updated in real time as well. And now we can go to time series and create charts. So here I'll select pressure H, L, and XL, and we can see 3 readings that are related to our pressure readings. Or I can select the formula reading for pressure, therefore we'll have a combined reading out there. Same for temperature. So let me remove the register readings directly, so I can just have already filtered and values where we have a temperature of 22.6 and a pressure of 1010 HPA. Perfect. I can download log of whatever's been happening to my computer, so you can leave it and see how it performed over a certain period of time. And then you can create additional charts as well. So if you want to monitor multiple registers and then again create logs, you're able to do that. So you can select whatever register you want and just go ahead with this. So here I select press out and I straight away can see live values for that. So let me go back to target, disconnect this, go back to configuration, and then show you how you can generate driver library from this. So click generate driver, select the target. In this case, let me use CMSys and click generate again. So now I will have a deterministically generated driver library based specifically on the configuration that we've tested. So what it means is that you can have all of your data type headers, register C implementation, setup, events that are reflection of the configuration that you validated in testing. Your C file for API accesses, here a CMSys specific implementation for this device as well. What I can also do, I can go back, download this driver if I need to locally, but also can copy this configuration and generate it for a driver for a new target. In this case, I can select Zephyr, click generate, and within a few seconds, I'll have an additional library. So, for example, you might have a new project that you're working on which changed the architecture, but you're utilizing the same component, or perhaps you made a decision to change the architecture of your device. So here you can see file structure is different, but ultimately all of the contents are reflected in your configuration. So thank you very much for your attention and enjoy Embed.